This video will run through the SEC 3100 transmitter menus, and so it's a normal operation now. To get to the menu structure, you go to Enter, and the first one is Eject Memory Card. If you have a data card or memory card inside the transmitter, which this one does, you can select that one to actually pull the memory card out. The next menu down is Information. What that one tells you is just the serial number of the unit, the rev of software that it's in, and to get back out, go to Enter. The next one is the main menu structure. To enter that, the first one is Calibration. This is where you can calibrate the sensor. So if you select that, this is where you sequence through in either zero or span, or zero and span the sensor. And we've already covered that in a different video, so we'll just go through and we'll show you the different ones. And it shows you the cal value of the span gas that you're supposed to apply to the sensor, which in this case it's 50% LEL. So we arrow down to Exit. The next one is titled Alarm. To enter that one, we have 3 different alarm relays in the transmitter head, and this allows you to program the relays for the alarm set points. So right now the low alarm is programmed for 10%, and to change it you would just select Enter, get the cursor there, and then you can use the up-down arrows to change the alarm levels. And once you select it, you've changed it. And you can also program the relays to be latching or non-latching. Normal is non-latching, so once an alarm is reached, it goes above that alarm level, the relay is energized, and then once it goes below that alarm level, the relay is normally de-energized, or de-energizes. And to change latching, also you can program it to be an audible alarm. So with that, you can just sequence through whatever you want to program the relay to be, and then move on to the next sequence, which is active. We have 2 selections here, active high and active low. Active high is probably the 90% of the time is how the relays are programmed. It's also the default setting. Active high means that the alarm relay will trigger on the rising edge, or as the gas concentration goes up and reaches the alarm set point, it will actually turn the relay on. And the only one that I'm familiar with that we use active low is when the sensor is, or the transmitter is used with an oxygen sensor, because typically you're looking for oxygen deficiency, so then you trigger on a falling edge. So once the alarm level goes below that alarm, then it will actually energize. But in most cases they're programmed to be active high. And then once you have your relays all programmed, you just arrow down to Exit, select Exit, and then you would just sequence through to your next relays. It's the same setup, but you can see how they're programmed. And you can change these set points. And then the last relay we have is a fault relay, and you have the same type of things, except for we don't have an alarm level. A fault is a fault or a not fault, so we can sequence through and you have the same active high, active low, and Exit. And then once you've made your changes, you can just arrow down to Exit. And then the next menu is what we call Relay. And here we can set in time delays in the relay. We can set an on delay time so that it's measured in seconds. So if we wanted to have the alarm come on after a certain amount of seconds that the gas is sensed, we can program in that time delay into this menu. So right now it'd be set for 2 seconds. So once the sensor went above that 11% LEL and stayed there for 2 seconds, then the relay would turn on. We also have off delay, so that this is used typically if the relay in the transmitter is used to turn on a fan, because if the alarm was going, or if the gas sensor was sensing the gas right at the alarm level, it'd be turning on, off, but you can program in an off delay again in seconds, so that'll keep that relay energized for a certain amount of seconds after the alarm goes away, in order to not burn out your motor on your fan. We also have the capability of changing the polarity of the sensor, so we can change it to be normally energized or normally de-energized. So what this indicates now is energized no, so that means that the coil of the relay is not energized, but it does become energized once the alarm level is reached. So if we want to normally energize that relay coil, and then once the alarm level is reached, it'll drop that coil out, opening up the circuit on the normally closed, normally open relays inside the head, we can program it to be that. And exit, and the same thing with the mid, same thing with the high. Oops. Fault, we just have we do still have the on and off delay and normally energized. And the fault relay is unique because it comes as a normally energized contact. It's the default setting for that, because if you do have a fault, you want to know about it, so that gives you a fail-safe operation of the transmitter, triggering off the fault relay. The next menu is the network menu. What this allows you to do is change the zone of the transmitter head. So again, you just select enter, go up or down to whatever zone you want the transmitter to be located in. You can also change the ID of the sensor. So you select enter and use the up down arrows to change the ID. Once you have the correct ID selected, select enter. Online is if you want to take the sensor off the data highway network. So typically it's set for yes, so it'll talk to the 3500 controller, but if you want to take it offline for some reason, you just select no, and now it'll turn itself off and it won't communicate back to the 3500 controller. Next one is a menu called hide. What that does is it hides the readings all the way up to the low alarm set point. So it would just show 0% LEL until it reached 11%, and then it would actually start reading. It's a feature that is really not used very much. Self-test. This allows you to actually test the sensor. The self-test, it just ramps the signal up from 0% LEL to 100% LEL, and then you can see the different alarm levels. Once it reaches a low alarm, it turns yellow, and then once it reaches the mid alarm, it turns orange, and once it reaches the high, it will turn red. And then it just continues all the way up to 100%. And then it will just go back to normal operation. And up in the upper right hand corner you can see that it's indicating it's in the self-test mode. And this would trigger any alarms back at the 3500 controller that this sensor is connected to as well. So to get back into the menus, see where we left off, self-test, date and time. This allows you to change the date and the time in the transmitter. The transmitter is battery backed up, so if it gets powered down, it retains the current date and time in the transmitter via the battery. 4 to 20 milliamp calibration. In this menu, you're allowed to set your 4 milliamps, and if you're not getting the correct reading, if you're monitoring it back at a PLC or something, the analog output of the sensor allows you to raise and lower the 4 milliamp or the 0 reading, as well as the full scale in this menu structure. Typically it's not oftenly used either. And then the last one is exit. So that's all the menus that are resident in the SEC 3100 transmitter.